topic electrical properties. Now, solids are of various types. They are conductors. You are already aware various metals around are conductors. Wood, plastic, rubber, they are insulators, and we know there are certain elements like silicon, germanium which are semiconductors. Metals popularly example as conductors, wood, plastic, rubber as an insulator, and silicon, germanium which are used in electronics, semiconductors. Now, what is the difference between conductor, insulator and semiconductor scientifically? Scientific difference is based on their electrical conductivity value, that symbol is K, and it is given by 1 upon resistivity. You all as a physics student are aware resistivity as a unit of ohm meter, therefore, electrical conductivity will have a unit of ohm inverse meter inverse. If K ka value is very high, more than 10 to the power 4, then it is said to be a conductor, right. The NCERT textbook gives a value from 10 to the power 4 to 10 to the power 7, but anyone greater than 10 to the power 4 is called as conductor. If the K value is between 10 to the power minus 20 to 10 to the power minus 10, lower value 10 to the power minus 20, higher value 10 to the power minus 10, that is very small. If very small electrical conductivity K value is existing, then such substances are called as insulator. Semiconductors have value of electrical conductivity K in a moderate range to 10 to the power minus 4 to 10 to the power plus 4, ohm inverse, meter inverse, then they are called as semiconductors, right. We are all aware most of the metals, whether you say silver, gold, iron, copper, they are all conductors. Even ionic solids in molten condition are good conductors. Insulators that immediately comes to our mind, wood, plastic, rubber, okay. They right, most of them are non-metals and most of them are molecular solids with no free electrons. They are insulator. Then metalloid like silicon, germanium are example of semiconductors. So, the entire learning process of conductor, insulator and semiconductor classification scientifically is based on electrical conductivity symbol K, which is given by the formula 1 upon resistivity. Then, what is the difference between a metallic conductor and an electrolytic conductor? Now, right, immediately if you say, right, conduction is due to free electron, then you should know it is a metallic conductor. It is due to free electrons, where electrons go from negative terminal to positive terminal. Free electrons are responsible for metallic conductivity, while conductivity due to free ions is called as electrolytic conductivity. So, free ions are responsible for electrical conductivity. Example that you are able to see is aqueous sodium chloride, where sodium ions are moving toward cathode and chloride ions are moving towards anode, that is a positive electrode. And here the examples are metals like silver, gold, copper and so on. Now, entire concept of electrical conductivity is based on band theory. What is the band theory? Band theory is based on free electrons concepts, and in this atomic orbitals of metal come together to become molecular orbitals. So, according to this band theory, which is actually a hypothetical, it is a theory proposed by us to understand conductivity. So, in this band theory, assumption is atomic orbital come together to become molecular orbitals, and this molecular orbitals, many molecular orbitals of various atoms or cluster of atoms. So, molecular orbitals of many cluster of atoms give rise to a band, and this band which is a cluster of molecular orbitals of various atoms, or of further two types. One is valence band and other is conduction band. Valence band is of atomic orbitals of inner valence shell. So, if you have a filled atomic orbital of inner valence shell, then they give rise to a molecular orbital, and accumulation of this molecular orbital is called as valence band. Conduction band. So, you can imagine this is a molecular orbital of inner valence shell of one atom. This is valence band of, or this is atomic orbital of inner valence shell of another atom, 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 and this gives rise to many atomic orbital of different energy, giving rise to a band called as valence band. While conduction band is of partially filled orbital, partially filled valence band, or partially filled orbital, or empty orbital called as conduction band. So, many atomic orbitals coming together, valence atomic orbital coming together, give rise to a conduction band. Now, there is a schematic diagram. This has been shown for magnesium. If you are able to see, this all are very tightly held by the nucleus, while 3s electrons are not tightly held and they are responsible for valence band. Remember, in magnesium 3s orbital is filled and give rise to a valence band. Now, 3p orbital of magnesium is empty. That 3p orbital of magnesium, which is empty, give rise to a conduction band. And what you are able to realize in magnesium, valence band and conduction band are so close to each other that the electron from 3s can easily jump to 3b by absorbing heat energy of surrounding. So, the difference is very small. So, electron can easily go from filled valence band to an empty conduction band at any given moment of time, making magnesium electrical conductor. So, this was a schematic diagram to understand valence band and conduction band. Now, if you see conductors, insulators and semiconductors from perspective of band theory. Now, it is assumed that in conductor this is valence band, while this is conduction band. What you are able to realize, valence band and conduction band overlap with each other. Because valence band and conduction band overlap with each other, electron can easily move to conduction band. Moment the electron goes to conduction band, they are responsible for conduction of electricity. So, why conductors conduct electricity? Because in conductors, valence band and conduction band overlap with each other. That is a small energy difference between them, or almost of the similar energy. Therefore, electron can easily move from valence band to conduction band. If you see insulator, the valence band and conduction band, that energy difference is very large. Such a large energy difference, the electron cannot move from valence band to conduction band even after providing larger amount of energy. So, even after providing larger amount of heat energy, electron cannot move. So, as per our logic, it is called as forbidden zone. Electron cannot go to conduction band ever. Therefore, insulator never conducts electricity. While in semiconductor, the difference is very small. That is the reason while semiconductors are at low temperature are working as good as insulators, and at room temperature they behave like conductors, because the gap between them is very small. So, semiconductor, conductor and insulator as per band theory have a difference. In conductor they overlap. In insulator the difference is very large, cannot be achieved by even heat energy. While in semiconductor the gap is very small, can be easily achieved by heat energy. In this case you do not require heat energy, that means conductors will conduct electricity even at low temperature, even at room temperature.